Okay, so solving non-homogeneous differential equation involves finding a complementary function in particular integral. Complementary function is nothing but the general solution of the homogeneous differential equation f of d of y equal to 0. And the particular integral is nothing but a particular solution of a given non-homogeneous differential equation. And in the last class, we have seen the comparison of it with the system of linear equations ax equal to b. Okay, and so we'll continue the discussion. Finding the particular integral depends on the type of differential equation, I said. For a particular type of f of d or q of x, there is a method of finding particular solution. So that we were discussing. Okay, so we'll continue the discussion. So we were in type 2. So type 1 is about 1 by d minus a of q of x equal to e power ax into integral e power minus ax q of x dx. If f of d equal to d minus a, and for any function q of x, this is the formula to be applied. Minus a means a, plus a means minus a, and after that we have seen a special case of it. After that we have seen a special case of it. If q of x is e power ax, then 1 by d minus a e power ax is going to be x e power ax. And generalization to this is 1 by d minus a whole power m e power x is x power m by m factorial into e power ax. Okay, and after that we have seen type 2. Type 2 is about 1 by f of t e power ax equal to 1 by f of a e power ax. As long as f of a is non-zero, you can always apply this formula. And we have seen some examples of it also. So whenever you have an exponential function, substitute that a here. So if it is non-zero, then this is going to be the answer. And sometimes denominator may give 0. Okay, so 2 square minus 4 minus 4 is 0. So in that case, I told you to factorize this, and factorize in such a way that which factor is giving 0, that you operate at the end. Okay, then you will get the answer quickly. If you are operating that initially, then you may get a longer expression, and answer may take time. And using type 1 and type 2, we have solved one problem of this type: d square minus 4d plus 4 of y equal to cos h 2x. And we computed a complementary function by solving the homogeneous differential equation. Okay, and depending on the roots, we will be writing the general solution, that we are writing it as complementary function or yc. Then we formed a particular integral, and f of d is nothing but this one, d square minus 4d plus 4, and this is d minus 2 whole square of cos h 2x. And like f of d, 1 by f of d is also linear operator, therefore you can operate this on sum. Constants can be taken out. Okay, so 1 by f of d of sum equal to sum of 1 by f of d. Then use your type 1 type 2 formulas. So this is application of type 1 formula, this is application of type 2 formula, and you got a particular integral, and add this particular integral to the complementary function, you will get the general solution of the differential equation. So this is what uh, we were discussing. Shall I proceed? Okay. I'll write down type 3. Type 3 particular integral. Okay. Okay. So type 3 like this: 1 by f of d square. Okay, and remaining times we are just going to list out the results. We are not going to see the derivations in detail. And derivation is basically like type 1. Okay, you will be seeing the if you consider the differential equation. Okay, then You solve it and apply 1 by f of t on both sides. You will get a particular solution. Okay. So if it is instead of function of d, it is a function of d square. It is function of d square and operating on cos ax plus b. It is operating on cos ax plus b. It is going to be 1 by f of minus a square. 1 by f of minus a square cos of ax plus b and 1 by f of d square sin of ax plus b. Sin of ax plus b is equal to 1 by f of minus a square sin of ax plus b, provided f of minus a square not equal to 0, provided f of minus a square not equal to 0. So whenever your q of x is like this, whenever q of x is cos of ax plus b or sin of ax plus b and your function is function of d square, then replace d square with minus a square. Okay, and if f of minus a square is not equal to 0, this is going to be the result. What is minus 2 square? Is it 4 or minus 4? Are you there?
Minus 4.
Minus 2 square is minus 4. Don't say that minus 2 square is 4. Minus 2 square is different from minus 2 whole square. Okay, I am talking about this. I am not talking about this. Is that okay? So you need to replace minus a square is negative. Okay. So for example, if you are having 1 by d square plus 1 sin 2x plus 3. What is this? According to this result, replace d square with the minus a square. That means what? 1 by, what is a here? A is 2. That is minus 2 square plus 1 sin 2x plus 3. Minus 2 square is minus 4. Minus 4 plus 1 minus 1 by 3 sin 2x plus 3. For example, if it is 1 by d power 4 plus 1, d power 4 plus 1 sin of okay, or cos of 2x, cos of 3x minus 1. How can I rewrite this? D power 4 can be written as d square whole square plus 1 cos of 3x minus 1. Now wherever d square is there, blindly replace d square with minus 3 square. So that means 1 by minus 3 square whole square plus 1 cos 3x minus 1. Can you tell me what is this? Minus 3 square is minus 9.
9.
Minus 9 whole square is
81.
81 plus 1, 82 cos 3x minus 1. Is that okay? So whenever you have like this, then you write it as a function of d square. Or sometimes it may be like this: 1 by dq plus d sin 3x. Then how do you do this?
Inside the boiler, inside the boiler or outside the boiler? Inside, okay.
You are seeing odd powers now. You don't have even powers. So how can I do this problem? How can I find out this particular integral?
Common.
So we want me to take d common, right? D of d square plus 1 sine 3x. Now can I write this as can I write this as 1 by d of 1 by d square plus 1 sine 3x? Now can I apply type 3 formula? Now it is function of d square. It is function of d square. So whenever d square is there, replace d square with the minus 3 square. So minus 3 square plus 1 sine 3x. So constant can be taken out. Constant can be taken out. What is this? Minus 9. Minus 9 plus 1 is minus 8. So this is minus 1 by 8, 1 by d of sine 3x. Now tell me what is this 1 by d? What is 1 by d? D is d by dx. What is 1 by d? Is it dx by d?
Integration.
Correct. Because 1 by d is nothing but a notation for d inverse. D inverse is inverse of d. What is inverse of derivative? Inverse of derivative is nothing but a integral. Am I right? So this is nothing but integral sine 3x. So what is integration of sine 3x? Integration of sine 3x is, please respond immediately.
Okay.
Minus 1 by 3 cos 3x. So this is 1 by 24 cos 3x. Is it okay? Is it fine?
Yes.
Now if it is like this, suppose if it is simply 1 by dq plus 1 cos x, cos let me say cos 4x, then what do you do? Dq plus 1 of cos 4x. Whenever odd power is there, you can always write the odd power as d into even power. Do you agree? So can I write it as d into d square plus 1? Into means actually composition, please remember. Okay, so decomposition d square of cos 4x, and wherever even powers are there, replace even powers with the minus a square. So this is going to be 1 by d of minus 4 square plus 1 cos 4x. Do you agree? So what is this? This is minus 16. Okay, so that means what? 1 by 1 minus 16d of 4 cos 4x. Again you are getting odd power. Again you are getting odd power. Then what do? multiply and divide with 1 plus 16d. Okay, so this is 1 plus 16d by 1 minus 16d into 1 plus 16d. So this is 1 plus 16d of a plus b into a minus b. A plus b into a minus b is a square minus b square. Okay, so this is 1 minus 16d. So this is 1 by a square minus b square means 1 by 1 minus 256. 16 square is 256 only. 256 b square of it is operated on cos 4x, right? Cos 4x. So cos 4x. Okay. Now replace d square with minus 4. So this is 1 plus 16d of 1 plus 16d of, okay, 1 by 1 minus 256 into minus 4 square minus 4 square minus 4 square of cos 4x. So this is a constant. This is a constant. Constant can be taken out. Okay, 1 plus 16d you operated on cos 4x. What is 256 into 16? Please compute in your calculator.
4096.
2000. Please tell me the simplification.
4000.
1 plus 16d.
4096.
4096 plus 1. 4097, right? 1 by 4097 of cos 4x. Cos 4x you take out. Sorry, constant you take out. 1 by 14097 of 1 plus 16d of cos 4x. So you operate 1 on cos 4x, 16d on cos 4x. So what is this? 1 by 4097 cos 4x plus 16 times derivative of cos 4x. What is derivative of cos 4x? Minus 4 sin 4x. So what is the final answer? Okay, 1 by 4097 cos 4x minus 64 sin 4x. Is that okay? Did you understand?
Yes, sir.
So whenever even powers are there, always write even powers as powers of d square. Replace d square with minus a square. Even if you have odd powers, you can always write odd power as into even power. That even power you write it as d square power and replace d square with minus a square. Finally, you will get a d in the denominator. Then multiply and divide with corresponding term, okay, proper term, so that you will get in the denominator form a square minus b square. Again, you apply type 3 form. Is that fine? Okay. So let us solve. Okay. Solve d square plus 9. Okay. Solve d square plus 9. Let me t square plus 9 of y is equals to d square plus 9 of y equal to cos 2x plus sin 2x. Cos 2x plus sin 2x. Cos 2x plus sin 2x. So, what is solving a non-homogeneous differential equation involves? It involves computation of complementary function as well as particular integral. All of you find out the complementary function first. For the complementary function, what you have to do? Consider homogeneous differential equation. T square plus 9 of y equal to 0. Write down the auxiliary equation. What do you mean by auxiliary equation? Replacing t with the r. So r square plus 9 equal to 0. Find out the roots. What are the roots? R equal to plus or minus I3. So what is A? What is B here? It is A plus or
A0,
minus A, correct, A0, B3. If it is A plus or minus IB, then it is going to be e power ax into cos bx plus sin c1 cos bx plus c2 sin bx. Here A0, so e power 0x into c1 cos 3x plus c2 sin 3x. That is a complementary function. Therefore, what is yc? Simply c1 cos 3x plus c2 sin 3x. Okay. So a minus ib, a plus ib. The general solution is e power a c1 cos bx plus c2 sin bx. In our case, a equal to 0. You are getting plus or minus 3i. So a is 0. B is c1 cos 3x plus c2 sin 3x. Okay. So then what is yp? Yp is 1 by f of t. What is f of t? D square plus 9. Okay. Cos 2x plus sin 2x. And you know, it is a linear operator. 1 by f of t is also linear operator. So operate this on each of the term. So I can write this as, so yp can be written as, okay, so 1 by d square plus 9 cos 2x plus 1 by d square plus 9 sin 2x. Okay, so what I did, I applied. Okay, we have some more. One second. Okay, so I have taken this 1 by d square plus 9 to each term. Why? Because it is a linear operator. Okay, so we can do that because of linearity. Therefore, it is going to be, okay. So 1 by d square plus 9 of cos 2x plus 1 by d square plus 9 of sin 2x. Then you apply type 3 formula to each of the term. So it is in terms of d square. So wherever d square is there, replace d square with minus 2 square. So 1 by minus 2 square plus 9 cos 2x plus 1 by minus d square, sorry, minus 2 square plus 9 minus 2 square plus 9 sin 2x. So it is going to be, so minus 4 plus 9 is 5, 1 by 5 cos 2x plus 1 by 5 sin 2x. Okay, so this is going to be 1 by 5 times, okay, cos 2x plus sin 2x. So that is particular integral. Therefore, what is the general solution? Okay, general solution is y equal to complementary function plus particular integral. Therefore, what is y? Complementary function is c1 cos 3x plus c2 sin 3x, and particular integral is 1 by 5 times cos 2x plus sin 2x. Is this clear to all of you? So we computed a complementary function, we computed particular integral, we added these two to find out the general solution. Did you copy? Shall I proceed?
Yes, sir.
Next, all of you write down type 5. Next, to write down type 5. Type 5 is a failure case. Okay, so 1 by d square plus a square cos ax plus b. 1 by d square plus a square cos ax plus b. If you try to apply type 4 formula, is this type 4 or type 3? Sorry, it has to be type 4, I guess. If you try to apply type 3 formula, if you replace d square with minus a square, what do you get? Minus a square plus a square is 0. So if f of minus a square is 0, you cannot apply, if f of minus a square equal to 0. Where is this? Not here. Here. If f of minus a square equal to 0, type 3 fails, you cannot apply type 3. If f of minus a square equal to 0, then you try to apply type 4. Okay. So minus a square plus a square is 0. So in that case, cos ax plus b is x by 2a sin of ax plus b. In this case, cos becomes sin. In type 3, cos becomes cos only. Type 4, cos becomes a sin. And 1 by d square plus a square sin of ax plus b. Sin of ax plus b equal to minus x by 2a cos of ax plus b. Minus x by 2a cos of x plus sin becomes cos. How do you remember this minus sign? Just like integration of cos is sin plus sin, integration of sin is minus cos. Is it okay?
Yes.
Now, for example, if it is something like this, 1 by d square plus 4 cos 2x, what is the answer? I can write it as 1 by d square plus 2 square cos 2x. So it is in the form 1 by d square plus a square cos ax. So according to type 4, it is going to be x by 2a, 2 into 2 sine 2x. Answer is x by 4 sine 2x. Okay. For example, if it is like this, 1 by d power 4 minus 4, d power 4 minus 16, d power 4 minus 16 sine 2x. If it is like this, d power 4 minus 16 sine 2x. How can I write d power 4 first? D square whole square. Don't write, just listen. D square whole square minus 16 sine 2x. And if I try to replace d square with minus 2 square, so minus 2 square whole square minus 16 sine 2x. And what is minus 2 square? Minus 4. Minus 4 whole square is 16. 0. You are getting denominator 0. So type 3 you cannot apply. Is this clear to all of you? Cannot apply type 3. Did you realize this point?
Yes.
Yes, sir.
In that case, what you want me to do? Hmm? So how do you do this problem then? D power 4 minus 16.
D square whole square minus 4 square.
D square whole square minus 4. That is what I did just now. No? That is giving 0. If I write
D square,
D,
D square
Plus
formula.
4 square into d square minus 4 square.
somebody said. So this is d square minus 4 into d square plus 4 sine 2x. Okay. So do you want me to take this order, or you want me to take this order, d square plus 4 into d square minus 4 sine 2x? Which one will give you quick answer? Both the orders are fine, but which one is preferable? Which order is preferable? This one or this one? First one or second one?
First,
First one. If you apply first one, what do you get? D square minus 2 square minus 2 square plus minus 2 square means minus 4. Minus 4 plus 4 0. If it is minus 4 plus 4 0, then you have to apply this formula, but this formula is containing x. So x into trigonometric function. To that function you have to apply this. But instead of this, if you prefer this order, d square, if you replace d square with minus 2 square is minus 4, minus 4 minus 4 minus 8. So minus 8 can be taken out. Then directly you can apply the type 4 formula. I said whenever the term is giving 0, that you apply at the end. Minus 4 plus 4 0. Minus 4 non-zero. So which order is preferable, first order or second order?
second.
Second order, okay? So instead of writing d square minus 4 into d square plus 4, I will be writing it as d square plus 4 into d square minus 4. Okay, so then what I will do, 1 by d square plus 4, 1 by d square plus 4 of 1 by d square minus 4 sine 2x. Then apply type 3 formula first. What is type 3 formula? Replace d square with minus 2 square. So 1 by minus 2 square minus 4 sine 2x. So minus 4 minus 8, that can be taken out. So this is minus 1 by 8, 1 by d square plus 4 means 2 square sine 2x. Now it is in the form type 4, 1 by d square plus a square sine ax. So what is the answer to this? Sine means you have to put minus. So minus x by 2a, 2 into 2 cos 2x. So what is the final answer? Minus into minus plus x by 8 4s are 32 cos 2x. Did you understand this process? Is this clear to all of you? Is that okay? So whenever a denominator is 0, if you substitute d square with minus a square, you try to factorize this. You factorize in such a way that the term which is giving 0, you operate at the end. Non-zero terms you apply first. Is it fine?
Yes, sir.
So this is type 4, okay? Next, write type 5. Write type 5. So type 5 is about polynomial. Okay? 1 by f of d, 1 by f of d of x power m. 1 by f of d of x power m. What is x power m? Polynomial, okay? Where m belongs to, where m is a natural number. Where m is a natural number. Okay, I will demonstrate this with one example. I will demonstrate with the example. So before that, write down the binomial expansion. Can you tell me the binomial expansion of binomial expansion of this? What is 1 minus 2 whole power minus 1? 1 minus 2 whole power minus 1. 1 plus t plus t square plus t cube plus and so on. Right? Similarly, what will be 1 plus t whole power minus 1 expansion? 1 minus t plus t square minus t cube plus and so on. Do you agree? What is 1 minus t whole power minus 2 expansion? Are you there? Are you with me?
Yes, sir.
Then please tell me this formula. What is 1 minus t whole power minus 2 expansion? 1 plus 2t plus 3t square plus 4t cube and so on. It is 1 plus t whole power minus 2. And so on. Is that okay? So you are going to use these facts. You are going to use these things, okay, in our formula. So note down this, and if it is like this, for example, if I want to write, if I want to find out 1 by d plus 2 of x square. 1 by d plus 2 of x square. How do I do this problem? Okay. So first write this as like this: 1 by 2 plus d of x square. Okay. So if I take 1 by 2, if I take 2, I'll just come in 1 second. Okay, so take constant common. Are you with me? So you take constant common, then what do you get? 1 plus d by 2 of x square. Now see d by 2 as t. See d by 2 as t. So can I write this as 1 by 2 1 plus d by 2 whole inverse of x square? Then apply binomial expansion. Okay, so 1 by 2 1 minus d by 2 plus d by 2 whole square minus d by 2 whole cube and so on of x square. Do you agree? So then apply each term on the polynomial. Okay, so 1 into x square. What is 1 into x square? X square minus 1 by 2 into derivative of x square. Derivative of x square is
2x.
2x. Okay, plus 1 by 4. This is 1 by 4. 1 by 4 of d square. What is d square of x square? D square of x square. D square means 2 times derivative. What is d square of x square?
2.
2. Minus 1 by 8. What is d cube of x cube?
0.
0. Then what will be d power 4 of x cube? X square? 0. D power 5 of x square? 0. All higher order derivatives will be 0 because it is a polynomial of degree 2. For a polynomial of degree 2, up to second order derivative you will have, third order derivative onwards 0. For a polynomial of degree n, up to nth order derivative you will have. After nth order derivative, all remaining derivatives, all higher order derivatives are going to be 0. So you need to collect the terms up to degree power n, up to power n only. Is it clear to all of you? Okay, so if it is x cube, you collect up to powers of 3. If it is x power 4, you collect up to x power powers of 4 and so on. Okay, so therefore this infinite series becomes a finite series now. So 1 by 2 times x square minus x plus 1 by, is it okay? So if I take LCM, 1 by 4 times 2x square minus 2x plus 1. Is it fine? This is okay? Did you understand this process? So whenever you have a polynomial, you write 1 by f of t into infinite series, then apply each term on the polynomial. Is it clear? Please respond immediately.
Yes, sir.
Say yes, sir. Then what is the difficulty in responding? Huh? So I'll write one more example. For example, if it is something like this: 1 by d square plus d plus 1. 1 by d square plus d plus 1 of x cube plus x minus 1. Let us say x cube plus x minus 1. Then can you tell me how to write this? Or I will write like this, minus 2. I will write like this, minus 2. D square plus d minus 2 of x cube plus x minus 1. Then can you tell me how to do this problem? How do you want me to rewrite this? Idea is to bring to one of these forms.
D plus D minus.
Write constant term first. Remaining terms you group. Then you take constant term common. If I take minus 2 common, what do you get? 1 minus d square plus d by 2. Do you agree?
Yes, sir.
Then is it not in the form 1 minus t? So this is minus 1 by 2, 1 minus of d plus d square by 2 whole power minus 1 of x cube plus x minus. Is it okay? Now this whole term you see it as t, 1 minus t whole power minus 1. What is 1 minus t whole power minus 1? 1 plus t square plus 2 plus and so on. Okay? So this is going to be minus 1 by 2, 1 plus t. What is t? D plus d square by 2 plus 1 plus t square. So d plus d square by 2. Like that up to, you want me to write one more term or sufficient?
Sufficient.
Sufficient. Think again. D is there. When you expand d square, here x cube is there. X cube means up to d cube we have to collect. D cube will be there only till this term, or it will not be there. D cube will not be there in the next term. Wherever d cube is there, you need to collect a d cube node. You can omit d power 4, d power 5 and so on. Because d power 4 of x cube is going to be 0. D power 5 of x cube is going to be 0. But d cube of x cube is non-zero, right? So if I write one more term, d plus d square by 2 whole cube. If I expand a plus b whole cube, first term will be d cube, no? Do you understand?
Yes, sir.
So I need to write one more term, right? But after I don't need to write the remaining terms, because d plus d square by 2 whole power 4 is going to be higher order. This will not contain d cube. Everything will be higher powers of d only, other than more than 3 power. Therefore, all these terms, when operated on x cube, it is going to be 0. Right? Now you just collect the terms up to, you collect the terms, you collect the powers of d less than or equal to 3. If the powers of d is greater than or equal to 4, you omit it. Okay, you simply omit it. So this is minus 1 by 2, 1 plus 1 by 2 into d plus d square plus 1 by 4 into, what is this? t power 4 plus 2d cube plus d square, or I'll write in the correct order as it is written here, d square plus 2d cube plus d power 4 plus 1 by 8 into which one you want me to collect? 1 by 8 is there, only d cube is sufficient because remaining terms will contain higher powers of d. Okay, so and so on, you can write and so on of x cube plus x minus. Is this point clear to all of you? I am not writing remaining terms. Why? Because remaining terms will contain powers of d more than 3. So when operated on this polynomial, it is going to be 0. Is that clear? Then you
Yes, sir.
operate each term on this polynomial. Okay. Then simplify it. I am going to write it on the next page. Shall I proceed?
Yes, sir.
Okay. So this is minus 1 by 2 into polynomial 1 into polynomial x cube plus x minus 1, x cube plus x minus 1. Next plus 1 by 2 into first you have to apply derivative. What is the derivative of this polynomial? D of this polynomial 3x square plus 1. Is it okay? So 3x square plus 1 is the first derivative plus second term is d square of x cube plus 1. That means you have to apply 2 times derivative. First derivative is 3x square plus 1. What is the second derivative? 6x.
6x.
6x, one derivative is 0, right? So plus 6x. So this is over. What is the next one? Plus 1 by 4 into okay, d square of this polynomial. Just now we did. D square of this polynomial is 6x plus d cube. 2 into d cube. What is d cube of this polynomial? D square is
6.
6x. D cube will be 6. So 2 times 6. So 2 times 6. Okay. 2 times 6. And d power 4 of this polynomial will be 0. Plus 1 by 8 times d cube of this polynomial is 6. Okay. So plus 0 plus 1 by 8 times d cube of polynomial is 6. That's it. Remaining terms are all 0. You simplify this now. Write it as a cubic polynomial. Please simplify for me. What is the simplified answer? There is only one term x cube and there is only one term x square. So plus 3 by 2 x square. Then combine x terms, combine constant terms and tell me. Is 1 plus 3 by 2? Is this 11 by 2? Am I right? X coefficient is here 1, here x coefficient is 3, and here x coefficient is 3 by 2. What is the constant term? Minus 1 plus 1 by 2 plus 6 by 2 is 3. Plus 3 by 4. You should have tell the answer by now. I am doing it for you. Is this 13 by 4?
Yes, sir.
And you're all students with young minds. You should not take this much time. No. By the time I started simplifying, you should be able to tell the answer. And this is simple algebra. Shall I proceed?
Sir, sir, instead of doing it in that way, can't we just factorize and do it, sir?
Which one?
Starting the d square plus d minus 2 can be written as d plus 2 and d minus 1.
D plus 2.
D
And
minus d minus 1.
that will increase your work.
No, sir. How would that increase my work?
If you want, you can do. There is no problem. You can write it as D plus 2 of 1 by D minus 1 of q plus x minus 1. Okay. You apply type 5 formula to that. Okay. Again, you apply this.
No, sir. Like, can't we increase like d minus
You want to apply partial fractions?
yes,
You can also apply partial fractions. You
or
can write
can't
it.
we do in that way like d minus 1 to the power minus 1 and d plus 2?
You do it and send me in WhatsApp. Okay.
Okay.
See, it is not the only way. As I said earlier, this way will give one particular solution, this way will give another particular solution. If you write this into partial fractions and do, that may give another particular solution. If you do some other way, that will give some other particular solutions. Is it okay?
It need
I
not be
just
same
want,
also.
need not be same. That is what I demonstrated in earlier methods. Even if you change the order, instead of d plus 2 into d minus 2, if you write d minus 2 d plus 2, you are getting a different particular solution. Is that okay? The
Okay,
intention
sir.
of writing in this formula is to tell that you just need to collect the terms up to powers of n, up to powers of d, up to degree less than or equal to n. Higher powers of n you can omit. That is what I would like to say. And even if it is polynomial, you don't need to write it as you don't need to write it as 1 by f of d of x cube plus 1 by f of d of x minus 1 by f of d of minus 1. Like that also you don't need to write down. That will again increase the work. It will take time. Okay. You take the whole polynomial as it is. Apply each term on the polynomial. Don't apply this 1 by f of d to each term in case of a polynomial. Is that fine?
Yes.
Right. Sometimes factorization also may not be possible. Okay. So in that case, you just simply apply this method. Okay.
Yes.
So where we are, we are here. Okay. So that is how we do a polynomial. So whenever you have a polynomial, try to use the binomial expansion. Try to use binomial expansion. All d terms you group together. You constant and you take separately, and take the constant term common. Take the constant term common, and bring it to binomial expansion form. So that is type 5. Now write down type 6. Type 6. Type 6. Type 6 is about shifting property. Type 6 is shifting property. What it says is 1 by f of t. 1 by f of t of e power ax into v of x. E power ax into v of x. V is some function of x. That can be any function of x. If this function of f of x is multiplied with this function of x is multiplied with exponential function, then write this exponential function outside. Replace d with d plus a. Replace d with d plus a. Operate this on v of x. Okay. So that is called the shifting property. Whenever your function is multiplied with e power x, shift e power x and replace d with d plus a and example. For example, if you have 1 by d minus 2 whole square, d minus 2 whole square of e power 2x into cos 3x, e power 2x into cos 3x. Can I apply this type 6 formula? Then what I have to do? Shift e power 2x to left hand side,
E power 2x.
replace d with d plus 2. So what is this e power 2x into 1 by replace d with the d plus 2 whole square minus 2. I think there is a mistake. Just replace d with the d plus 2. Remaining terms write as it is. Cos 3x. So what is this? E power 2x. D plus 2 minus 2 is 2. D square of cos 3x. Now can you tell me what is 1 by d square?
Minus a square.
Okay, I understand that. But what is the interpretation of 1 by d square? You said 1 by d means integration. What will be 1 by d square? Two times integration. 1 by d of 1 by d, no? Integral of integral. Do you understand? Do you understand? So what is one time integration? Sin 3x by 3. What is second time integration? Minus cos 3x by 9. That is what I said. That is what I said, right? Replace d square with the minus 3 square. What is minus 3 square? Minus 9 only. Minus 9 only. Can you see that? Wherever d square is there, replace d square with minus a square is it. Did you understand? 1
Yes,
by d
sir.
cube means 1 by d cube means 3 times integration. Okay. So this is 1 by minus 3 square cos 3x. So final answer is minus 1 by 9 e power 2x cos 3x. Okay. Shall I proceed?
Yes, sir.
Okay. So I'll just discuss one more type, and then we'll do problem on non-homogeneous differential equation, which will be combination of type 2, type 3, type 4, like that. Okay. So your q of x may be sum of exponential, trigonometric, or polynomial and trigonometric and so on. Okay. So let me complete that type also, type 7. Type 7. 1 by f of d, 1 by f of d operated on x into v of x. 1 by f of d operated on x into v of x. Okay. So if this is in the form, whenever your function is multiplied with x, whenever your function is multiplied with x, then apply this formula: x into 1 by f of d of v, x into 1 by f of d of v minus f dash of d by minus f dash of d by f of the whole square, f of the whole square of v of x. X into 1 by f of d v of x minus f dash of d by f of the whole square of v of x. F dash of d means derivative with respect to d. For example, 1 by d square plus 1 x sine 2x. Let us say we have like this: 1 by d square plus 1 x sine 2x. So according to this formula, what is this? X into 1 by d square plus 1 sine 2x minus f dash of d means derivative of f of d. What is derivative of d square plus 1 with respect to d? What is the derivative of d square plus 1 with respect to d?
2D.
2D.
That's it. 2d by t square plus 1 whole square of sine 2x. Then use your previous types to find out this. Depending on q, you apply proper type and find out the particular type. So each term in what type? It is in type 3. Do you realize this? So x into, now try to replace d square with minus 2 square first. That do it mentally. If this is non-zero, apply type 3. If it is 0, factorize it and apply type 4. Okay. So minus 4 plus 1 is minus 1 by 3. So this is minus 2 square plus 1 sine 2x. Write 2d outside. 1 by d square plus 1 of whole square of sine 2x. Okay. So this is x into minus 4 plus 1 is 3, minus 3. So minus 1 by 3 sine 2x minus 2d of. Okay. Now replace d square with minus 2 square. So that is 1 by, okay, minus 2 square plus 1 whole square of sine 2x. So what is the final answer? So this is okay. So x into minus 1 by 3 sine 2x, constant can be taken out, minus minus 4 plus 1 is minus 4 plus 1 is minus 3, minus 3 whole square is 9. So that is minus 2 by 9, minus 2 by 9. Now apply numerator. What is derivative of sine
Minus
2x?
4 by 9. 2
Cos
cos
2x
2x.
into 2.
So 2 cos 2x. 2 cos 2x.
Cos 2x.
That's it.
Minus
After that,
4 by 9
that's it.
cos 2x.
So you just multiply with x to each term and write down the final answer. So this is minus x by 3 sine 2x. Okay. Minus 4 by 9 x cos 2x. Minus 4 by 9 x cos 2x. Is this fine? Is that okay?
Yes, sir.
So whenever your function is multiplied with x, apply type 7. Whenever your function is multiplied with e power x, apply type 6. Okay. Now can you hear me?
Yes, sir.
Right. So I'm sharing the screen again.
Yes, sir.
Can you see this? Right. So now I shall give you a problem.
Yes, sir.
Okay. So depending on the nature of q of x and f of t, you solve the differential equation. Okay. So all of you take this problem, solve the following differential equations. Solve the following differential equations. So note down the first problem. Yeah, if you take a problem like this, d square minus 2d plus 1 of y equal to x e power x sin x. X e power x sin x. So you are asked to solve this problem. So how do you solve this problem? First, which one you have to consider? You have to consider the homogeneous differential equation. D square minus 2d plus 1 of y equal to 0. What is the auxiliary equation? Auxiliary equation is r square minus 2r plus 1 equal to 0. Okay. So what are the roots? R minus 1 whole square equal to 0. R equals to 1 and 1. So what is complementary function? tell me? When the roots are equal, what is the complementary function?
C1 e power x plus x C2 e power x.
Plus
After simplification, I can write it as C1 plus C2x into e power x.
e power
Right?
x.
So what is particular integral 1 by f of t of q of x? What is q of x? X e power x sin x. X e power x sin x. Okay. So tell me which type you want me to apply first. You can see it as x into v of x, or you can see it as e power ax into v of x. So you want me to apply type 5 formula or type 4 formula first? You want to see it as x into v of x, or you want to see it as e power ax into v of x? See this, denominator is d minus 1. So it is easy to apply exponential shifting first. X into sin x. What is the advantage in writing like this? You will be shifting e power x outside and replacing d with d plus 1. What is x coefficient? What is a here? 1. So d plus 1 minus 1 whole square of x sin x. So this is what e power x into d plus 1 minus 1 is d square of x sin x. What do you mean by 1 by d square? I said 2 times integration. Either you apply 2 times integration or you apply type 5 formula. What type 7 formula? X into v of x. What is x into v of x formula? X into 1 by d square of sin x minus d square derivative is 2d. 2d by d square whole square of sin x. Is it okay? So this is e power x into replace d square with the minus 1 square. Okay, so 1 by minus 1 square sin x minus. Okay, so you just write it as 2d of 1 by minus 1 square whole square sin x. Just stick to the basics. Then apply numerator. So this is minus 1 square. So this is e power x into minus x sin x minus 1 whole square is 1. Okay, so 2 times derivative of sin x is cos x. Is this this is particular integral? Do you understand? Therefore, what is
Yes, sir.
general solution? Therefore, the general solution is y equal to yc plus yp. Therefore, y equal to c1 plus c2x, okay, minus e power x into 2 cos x plus x sin x. 2 cos x plus x. That's it. That is going to be the sum of complementary function particular integral, which will be the general solution of the differential equation. Okay. So like this, I can create n number of problems. I can create n number of problems and do. Shall I proceed?
Yes, sir.
Right. Take one more problem. Next one. Okay. So next one, I will go into the next page. Problem number 2. D square minus 1 of y is equals to x square cos x square write like this, d square plus 1 d square plus 1 d square plus 1 of y equal to x square sin 2x. X square sin 2x. So first consider the homogeneous differential equation. Sorry, homogeneous means right hand side 0. Write down the auxiliary equation. Find out the roots, and then depending on the nature of the roots, write down the complementary function. A is 0, B is 1. So e power 0x is 1. C1 cos, what is A, B here? 1. C1 cos x plus C2 sin x. Is that fine? A
Yes,
plus
sir.
or minus IB. Okay, so particular integral. What is particular integral? 1 by d square plus 1 x square sin 2x. So tell me how to do this problem. X square sin 2x. You have the formula for x into v of x. You don't have the formula for x into x square into v of x. So how can we write this?
Polynomial.
Polynomial is multiplied with trigonometric function. No, you cannot directly apply. You cannot apply the type 5 formula because polynomial is, if it is only polynomial alone, then nth degree derivative of a polynomial will be constant. If that polynomial is multiplied with trigonometric function, the number of terms keep on going. There is no end to it. Did you realize that point?
Yes, sir.
So you cannot directly apply type 5. At most you can write it as x into x sin 2x. Can I write like this? In this case, what is v?
X sin 2x.
So
X
apply x
sin
in,
2x.
no apply, so recursively apply the type 7 formula. That means what? X into uh, sorry, x into 1 by d square plus 1 of x sin 2x minus d square plus 1 derivative is 2d by d square plus 1 whole square of x sin 2x. That's it. Like this only you can do. Then to each term you apply x into v formula, then apply numerator and get the answer. Is that okay? So it's a long process. Patiently you have to do one by one. Just follow. How can I apply this? What is the formula, types and formula for this? Okay, or you want me to do it separately and substitute in this term? Shall we do it parallelly, or you want to do it separately and substitute here in this expression? Which one you would like to do? Shall we go parallelly?
Parallel.
Right. So in this case, what? So how do I find out 1 by f of into x into v? So in x into 1 by d square plus 1 of sin 2x minus d square plus 1 derivative is 2d by d square plus 1 whole square of sin 2x. This is over minus 2d you keep as it is. This is 1 by d square plus 1 whole square of x sine 2x. That we will do in the next step. Okay. So this is going to be x into what is 1 by d square plus 1 of sine 2x. When I replace d square with minus 2 square is minus 4 plus 1 is minus 3. So that is minus 1 by 3 sine 2x minus 2d of so minus 4 plus 1 is minus 3 whole square is 9. Okay, so plus 1 by 9 sine 2x. This is over. Close the bracket, minus 2d, open the brackets, apply x into v formula, x into 1 by d square plus 1 whole square of sine 2x. Find the derivative of d square plus 1 whole square. What is the derivative of d square plus 1 whole square? 2 times d square plus 1 into d square plus 1 derivative is 2d by d square plus 1 whole square is whole power 4 sine 2x. Is this clear? Is this clear to all of you? Please tell me. I
Yes,
found the
sir.
derivative, I did the derivative here and took the square of the denominator and substituted here. Is it okay? If this is fine, then simply complete this. Okay. So what is this? X into x. So minus x square by 3 sine 2x. Derivative of sine 2x is 2 cos 2x. 2 2s are 4. Okay. So minus 4x by 9 cos 2x. This is over minus 2d times x into replace d square with minus 2 square minus 4 plus 1 minus 3 whole square is 9. So x by 9 cos 2x, x by 9 sin 2x minus 2 2s are 4 d square of d square of d is d cube. So d cube plus d cube plus d of replace d square with minus 2 square plus 1 minus 4 plus 1 is minus 3 whole power 4 is 81. So 1 by 81 sin 2x. Do you agree? Agreed or not?
Yes, sir.
So finally, derivative is here. You apply derivative to each term. Okay. So don't forget any point. So minus x by 3 sine 2x minus 4x by 9 cos 2x minus 2 by 9 derivative of x sine 2x. Okay. Minus 8 times d power 4 of d power 4 plus d of d. D of d is d power 4. D of d is d square. Okay, d of d cube is d power 4 plus d square by 81, right? By 81 of sine 2x. Is this fine? So this is minus x by 3 sine 2x minus 4 by 9 x cos 2x minus 2 by 9. What is the derivative of x sine 2x? Sine 2x plus 2x cos 2x. Do you agree? UV rule. Sine 2x plus 2x cos 2x. Okay, na? Minus 8 by 81. 4 times derivative of sine 2x. Cos minus sine minus cos sine. Is that okay? 2 power 4. So 2 power 4 of sine 2x d square of sine 2x cos minus. So minus 2 square of sine 2x. Do you agree? 4 times related to 2 times related. Okay, na? You just simplify all these terms. You just simplify all these terms and tell me the final expression. I want you to simplify this and tell me the final expression. Why did I write x cube here? What is x into x?
X square, sir.
It
X
has to be
square.
x square, right? So it has to be x square. Is there any mistake? X square by 3, x square by 3, x square by 3. Is it fine? Is
Yes,
there
sir.
any mistake? Remaining are all fine, right? Okay. Now tell me the simplified expression. All of you simplify it and tell me. So final expression would be like this. Just verify whether it is right or wrong. Minus 8 by 9 x cos 2x minus x square by 3 sin 2x plus 26 by 27 sin 2x. Verify. Okay, so now you can see the complexity, right? So if I instead of x square, if I write x cube, it will be recursive application of x into b of x 3 times. It will be even more difficult. Okay, so generally you don't get x cube x power 4 like that. I just want you to do this problem. Shall I proceed to the next page?
Yes, sir.
Oh, okay, so note down and verify this later. Next problem, d cube minus d cube minus d of y, d cube minus d of y is equals to 2x plus 1 plus 4 cos x plus 2e power x. 2x plus 1 plus 4 cos x plus 2e power x. Can you tell me q of x is combination of how many functions? It is a combination of exponential, trigonometric
Trigonometric.
and polynomial. What is polynomial
Polynomial.
here? Polynomial is 2x plus 1. Is that okay?
2x.
So group 2x plus 1, 4x plus 4a cos x is one term, 2e for x is one term. So find out the general solution of homogeneous first. Auxiliary equation r cube minus r equal to 0, r into r square minus 1 equal to 0. This implies that r equal to 0 minus 1 plus 1. Therefore, what is complementary function? C1 e power 0x plus C2 e power minus x plus C3 e power x. Do you agree?
Yes, sir.
So apply particular integral. What is yp? Yp is 1 by d cube minus d of 2x plus 1 plus 4 cos x plus 2 e power x. Okay. So this can be written as 1 by d cube minus d of 2x plus 1 plus 1 by d cube minus d of 4 cos x plus 1 by d cube minus d of 2 e power x. If you want, you find out each particular integral separately and substitute in this formula. That will be better, I guess, because too many terms you may get confused. Parallelly, if you are doing if you omit writing any one term, that may lead to wrong answer. So 1 by d cube minus d, you do it separately. 1 by okay. So 1 by 2x plus 1, you do it separately, and so on. So how do you do 1 by d cube minus d of 2x plus 1? I can write it as 1 by d into d square minus 1 of 2x plus 1. Am I right? So then I can write it as minus 1 by d of 1 by 1 minus d square of 2x plus 1. So this is minus 1 by d of 1 minus d square whole power minus 1 of 2x plus 1. So you just collect up to powers of d, because d square of 2x will be 0. So 1 plus d square. Here itself you are getting d square because this whole term is t. You consider this whole term as t. 1 minus t whole power minus 1 is 1 plus t square plus and so on. So 1 plus d square plus and so on of 2x plus 1. So this is minus 1 by d of 1 into 2x plus 1 is 2x plus 1 plus remaining d square of 2x plus 1 is 0 plus 0 plus and so on. So this is minus 1 by d of 2x plus 1. What is 1 by d? What do you mean by 1 by d?
Integral.
So integral of 2x is x square plus integral of 1 is x. So this is minus x square. Is that fine? So this is minus x square plus, how do you find out 1 by plus 4 is okay, constant. I can write down here. What is d cube minus d? What is d cube minus d of cos x? Then I can write it as d into d square minus 1 of cos x. This is 1 by d square minus 1 of cos x. Replace d square with minus 1 square. Minus 1 cos x. That is minus 1 by 2. 1 by d means integration. Integration of cos x is sin x. So that is minus 1 by 2 sin x. Do you agree?
Yes, sir.
One last thing is dq minus d e power x. So 2 you write down constant outside. So 1 by dq minus d. So 1 by dq minus d e power x. What is this? 1 by d into d square minus 1 of e power x. I can write this as d into, okay, d minus 1 into d plus 1 of e power x, or I can write this as 1 by d minus 1 of, okay, 1 by d minus 1 of 1 by d square plus d square plus d e power x. This is 1 by d minus 1 of, substitute d with 1 e power x, 1 by f of t e power x is 1 by f of a e power x if f of a is non-zero. So 1 plus 1 is 2. So 1 by 2 e power x. So 1 by 2 you take outside. 1 by d minus 1 e power x. 1 by d minus a e power x is x e power x. So this is x e power x into 1 by 2. Is this clear to all of you? Special case 1 by d minus a e power x is x e power x. Here a equal to 1. Agreed or not?
Yes, sir.
So let it, you substitute that x by 2 e power x here plus x by 2 e power x. So if I write the final answer, so write down the final general solution. Therefore, y equal to yc plus yp is the general solution equal to c1 plus c2 e power minus x plus c3 e power x minus x square minus 2 sin x plus x e. That's it. Do you agree?
Yes,
So
sir.
you need to have patience. Okay, you need to have clarity on applying the formula and do it slowly but correctly. Then you will get the answer. Okay, so I shall give some more problems. Okay, I shall post those homework problems in WhatsApp. You try to solve those problems. Is that okay?